Okay, so on this lesson, we're going to continue with solving systems, but instead of it being a 2x2, it's going to be a 3x3. So a 3x3 system of equations has 3 variables and 3 equations. So the solution to a 3-variable system may be represented by, instead of an ordered pair, it's an ordered triple, because there's 3 values. Okay, so these are a little more challenging, but we're going to be solving today. We're just solving them by substitution. So we've already gone over how to substitute. Okay, so we're going to isolate a variable in one equation. When you isolate a variable, it's easier if you isolate a single variable. So remember, we talked about that on the 2x2s. Okay, so first step is to isolate a variable in one equation. So I'm going to choose just this first equation. Let's just solve for a. So that means I would need to subtract b and subtract c. So I should have a equals negative b minus c plus 6. So all I did was I isolated my a there. So I subtracted the b, subtracted the c on both sides. Okay, so what we're going to do now is we're going to take that and substitute it in to that second equation. So I'm going to have 2, now I know a, and then minus b plus 3c equals negative 59. So in place of my a, I'm plugging in what a equals. So negative b minus c plus 6. Okay, so I'm going to need to distribute. That's negative 2b. I'm going to go back and use a different color. So negative 2b minus 2c plus 12, and then just bringing everything else down. So after I distribute, I need to combine my like terms, because notice I have similar terms on the left side of the equation. So I'm going to combine my b's, and then I'm going to combine my c's. Make sure to always look at the sign in front of each one. So when I combine my b's, I get negative 3b. When I combine my c's, I get 1c, and then I have that plus 12 equals negative 59. Okay, so once we substitute it in and we distribute combined like terms, we need our variables on one side, our constant on the other. So I'm going to go ahead and subtract 12. So that's negative 3b plus c equals, that's negative 71. Okay, so there's one equation. Now I'm going to substitute that same thing from a into that third equation. So I'm going to come over here. So in place of a, which is the very first one, I'm going to substitute that in, minus b minus c equals negative 12. So again, I'm using this equation. In place of a, I'm going to substitute that in. So when I substitute in, that's negative b minus c plus 6. Okay, so notice I don't need to distribute on this one because there's nothing in front of my parentheses. So I'm just going to rewrite negative b minus c plus 6 minus b minus c equals negative 12. So now I'm going to combine my like terms. So I'm going to combine the negative 1b's. I'm going to combine the negative c. So that's going to be negative 2b minus 2c plus 6 equals negative 12. Okay, so same thing as the last one. I want b and c on one side, the constant on the other. So I'm going to subtract 6. So that'll be negative 2b minus 2c equals negative 18. Okay, so after you have done that, you always want to see if you can reduce your equation. So if you notice all of these, I can divide by negative 2. So this one I wasn't able to do that. So if you notice that you can divide all of them by the same number, you can reduce it. So that will be a b plus c equals 9. So those are the same exact thing. So if you don't notice that you can reduce it, it's okay. You should be getting the same answer, no matter if you reduce or not. Okay, so now what I'm going to do is I'm going to use those two equations that we just found, this one here and this one here, because notice now we only have two variables. So this is what we saw on the first lesson. We only had two variables that we were solving for. So I'm going to combine those two. We are still using substitution, so it doesn't really matter which one you substitute in for, because you're going to be solving for both. Okay, so I'm just going to, since this one's easier, I'm just going to find B. So B equals negative C plus 9. Okay, so now what I'm going to do is I'm going to substitute that in for my B on this equation. So I'm going to have negative 3, and then I'm plugging in for B plus C equals negative 71. So in place of B, I'm putting what B equals, negative C plus 9. So I'm going to distribute. So that's going to give me a positive 3C minus 27 plus C equals negative 71. So notice now I just have one variable. I have C's. I'm going to combine them. That's 4C minus 27 equals negative 71. And then I'm going to add 27. So that I'm running out of room. So that's 4C. And that's negative 44. All right, so once I do that, divide by 4, and we have our C value. C equals negative 11. All right, so once we know C, then we can solve for another variable. So what I would suggest is use this equation that we just found. Use this one because it'll be easy to find B. So I'm going to substitute that in. So that is B equals, it's negative, but I'm plugging in a negative 11 for C. So overall, that's going to make that a positive 11 plus 9, which will give you 20. So we found B to be 20. And then at the end, we're going to plug into one of our original equations. So looking back up at the top, it doesn't really matter which one. I think the first one's probably the easiest. A plus B plus C equals 6. So I'm going to plug that in. So A plus B plus C equals 6. I now know the value of C and B, so I'm going to substitute that in. B is 20. C is a negative 11. So that's A. That gives you plus 9 equals 6. Okay, so then subtract 9, and you get A equals negative 3. All right, so on an ordered triple, X comes first, and then your Y, and then your Z. So when you're using different variables, you're going to put it alphabetically. So A is going to come first, negative 3. B is going to come second, 20, and C will come third. So there's your ordered triple. Now, to check these solutions, we can plug in negative 3 for A, 20 for B, and negative 11 for C into our original equations at the top, and it should equal 6 on the first one, negative 59, negative 12, if that is correct, the correct solution. It's the point that they have in common. So again, this is very similar to what we were doing, but we have 3 variables this time that we're having to solve for. Let's take a look at the back. Okay, so the back, these are special solutions. So sometimes we're not going to be able to get that ordered triple. So it says 3 by 3 systems of equations can have solutions at exactly 1 point, such as an XYZ, an ordered triple. This occurs when the 3 planes represented by your 3 equations intersect at one location. So remember, on a 2 by 2, it was the point that they had in common. Same thing here. A z-axis is 3-dimensional. That's what you see in this picture. It says if the system has no solution, one of the variables will eliminate, resulting in a false statement. So you won't have a variable anymore, and it will be something like this, where 0 cannot be 1. So it'll be a false statement. That means there's no location where they intersect. If the system has infinitely many solutions, one of the variables will eliminate, and it will result in a true statement. So an example would be 0 equals 0. That's true. Okay, so infinitely many means they have every single point in common. So it's stacked exactly on top of each other. So basically it's the same exact line. Okay, so let's solve number 2. So we're using substitution again. So I want to solve for a single variable. So pay attention to all 3 of your equations. I notice here that I just have a y here. So I'm going to go ahead and solve for y, solve for my single variable. So step 1. So I'm going to get y equals negative 3z plus 6. Okay, so what I'm going to do here is now I'm going to substitute that in. It doesn't matter which one you substitute it in for, so your choice. It has to be the first equation or the third equation. So I'm going to substitute that in. So I have x minus 2 minus z equals 3. So in place of that y, I'm inserting what it equals, negative 3z plus 6. So I'm going to distribute. So that's going to give me plus 6z minus 12 minus z equals 3. Okay, so once we do that, then we need to combine our like terms. So the only like terms I have are the z's. So I have an x, and then when I combine the z's, I get 5z minus 12 equals 3. So remember we said earlier we want to get the variables on one side, the constant on the other. So I'm going to add 12. So that's going to be x plus 5z equals 15. Okay, so now I have to, step 2, now I have to insert this same equation, but now into the third equation. So I have 2x minus 3. In place of your y, you're going to insert plus z equals 9. So in place of my y, I'm inserting it, negative 3z plus 6, and I'm going to distribute. So I'm going to get 2x plus 9z minus 18 plus z equals 9. So I'm going to combine my like terms. So I can combine the x's. Oh, there's only one x, so 2x. And then I can combine the z's. So that'll be a 10z minus 18 equals 9. So again, variables on one side, I'm going to add 18. Okay, so notice now I have 2 equations that both have only an x and a z. So I'm going to combine them by using substitution. So notice this pink equation here has a single variable. It makes it easier if you solve for a single variable. So I'm going to get x by itself. That's going to be negative 5z plus 15. I'm going to substitute it into my blue equation. So 2 in place of x, I'm substituting it in, plus 10z equals 27. So when I substitute in, it's negative 5z plus 15 in place of your x. So I'm going to distribute. That's going to be negative 10z plus 30 plus 10z equals 27. Okay, so combine your like terms. Notice my z's give me a 0. So I'm no longer have a z. So don't put z because that would be a 1z. So I have a 30 equals 27. That is not true. 30 does not equal 27. So remember we said up at the top, if your variables eliminate, you no longer have a variable, and it's a false statement, that means there's no solution. So 0 with a slash. So what that tells me is they will never intersect. They'll never have a point in common. So let's take a look at example 3. So first thing, I want to solve for a single variable, so pay attention to your equations here. It doesn't really matter which one you do. So I'm just going to solve for A on the last one, but again, it doesn't matter. So A, move over your B, so minus B minus 3C plus 15. But again, it doesn't matter. So I'm going to start with my first equation, and I'm going to substitute in place of your A, you're putting what A equals, just rewriting that top equation. So I'm going to substitute whatever A equals into that first equation, negative B minus 3C plus 15. So when we distribute, that's negative 2B minus 6C plus 30, and then bring everything else down. Combine your like terms. So I have B's that I can combine. Always pay attention to the sign in front. That's a negative B. And then I have a negative 6C minus C is a negative 7C. And then notice we have a constant. Remember, we want to move all of our constants, which is just the numbers, to the other side. So subtract 30. You get negative B minus 7C equals negative 25. Okay, so I noticed that all of these are negative, so you're welcome to divide all of it by -1 and just change it to this. It's the same thing. If you don't do that, it's okay. You're going to get the same answer. So that way, if all of them are negative, I can change them to all positive. Just change the sign. It's like dividing by -1. All right, so now what I'm going to do is I'm going to take that, what A equals, and now substitute it into that second equation. So I have a 4 in place of A. I'm putting what it equals from that very first step we did. So in place of your A, you're putting negative B minus 3C plus 15. So when I distribute, that's negative 4B. That's minus 12C plus 60, and then bring everything else down. So combining your like terms, we can combine the B's, that will make a negative 2B. Combine the C's, again pay attention to the sign in front, that's negative 14C. And then bring your 60 down equals 10. So moving your constant over, so that's negative 2B minus 14C equals negative 50. Again, I noticed that all of them are negative, so I'm going to divide all of them by -1, which will change all of them to positive. If you don't do that, you're still going to get the same answer. Okay, so once we have now two equations that have two variables, we're going to use those and substitute in. So notice I see that the only single variable is this one, so I'm going to go ahead and rewrite it with B isolated. And I'm going to substitute that in. So I'm going to have 2, and then I'm plugging in for B. For B, it equals negative 7C plus 25. So when we distribute, that's negative 14C plus 50 plus 14C equals 50. So after we distribute, notice we can combine the C's. They cancel, they equal 0. Negative 14 plus 14 is 0. So I'm left with 50 equals 50. So remember, these are special cases. If your variable is eliminated, you're looking at your statement to see if it's true or false. It's true, which means there's an infinite number of points that they have in common. So infinitely many solutions. I don't care if you write IMS as long as you know what it means. So infinitely many solutions. They have every single point in common. So those are some special cases where your variables cancel out and you no longer have a variable to solve for. So check your statement, see if it's true, see if it's false, and that will determine if it's a no solution or infinitely many. Okay, the back. Super easy back. So what you're doing here is you're going to identify if they're solutions. So it says identify solutions to a system of linear equations by substituting the values of the potential solutions into each equation. So in order for an ordered triple to be the solution, it must be true for all equations in your system. So remember I said if there's multiple or different variables other than x and y, whatever comes first in the alphabet will be first on your ordered triple. So this is H, this is J, and this is K. So I'm going to substitute that in. So this first equation is -7 plus 2. Instead of J, I'm putting 3. Instead of K, I'm putting a 1. So you're going to work it out and check it. That's -7 plus 6 plus 1. So left to right, that's -1 plus 1, which does give me 0. So that one works. Now, you have to check it for all three because it's what they all have in common. So I would have a 2 instead of H, -7, minus J is 3, plus 10 times 1 equals -7. That's -14 minus 3 plus 10 is a -7. So working left to right, that's -17 plus 10, which does equal -7. So again, you have to plug it into all three. It could work on the first two, but not the last one. So -7 plus 4 times 3 minus 2 times 1 equals 3. That's -7 plus 12 minus 2 equals 3. Work from left to right. 5 minus 2, which does equal 3. Okay. All right, so since it worked for all three, yes, this is the correct solution. So you're determining if they are true or false. If it works for all three, it is the solution for the system. So I want you to try B, plug in. First one's A, B, C. Plug them in, make sure it works for all three. You can pause it until you're done. I'm about to tell you the answer. The first one works, the second one does not, the third one does not. So this is a no. That would not be the correct solution.